Okay, so in this video, we will talk about the regression, while the correlation we talked about in the last video is a relationship between two variables. So we are looking for a relation between two variables, and it says as a relation. For the regression analysis, we are talking about an independent variable is predicting a dependent variable in case of a simple linear regression. And in case of a multiple regression, we're saying that multiple independent variables are predicting one dependent variable. So remember the difference between a simple linear regression and a multiple regression. Okay, so now we should use SPSS to do the regression. So we go to analyze regression, and then we go to linear. We're doing the linear regression now with two variables. And we use as dependent variable, we use the desirability to buy economy cars. Let's stick to that dependent variable. And then as independent variable, we can put size of ohm. Okay, so in this case, we are having a simple linear regression. So we're saying that indeed the size of hometown or city is predicting the willingness, the desirability to buy economy cars. So here we have one dependent variable, one independent variable. If we want to run a multiple regression, which is something that you will do in your assignment, we choose other independent variables here. So we can add, for example, gender, we add marital status, okay, and we can also add, let's see, I'm worried about global warming. We can add maybe income. Okay. Then what we do is to check for multicollinearity. So we need to make sure that we are not using some independent variables that are measuring the same thing. So we go to statistics and we click collinearity diagnostics. So this part will tell us if there is a multicollinearity. Let's remember that we need a VIF less than 10. So if we have a VIF less than 10, we're good to go. If we have a VIF more than 10, there is multicollinearity. So we need to do something to fix something with regard to our independent variables, okay? So we hit continue, we do paste, we go to our syntax and we select and play. So first we will get our ANOVA table, and then we will have the coefficients table and the model summary table. So the model summary table and the ANOVA table are more general, like the overall result of your regression. And this table, the last table, this, which is not the last table is the collinearity diagnostic, but the coefficients table is telling you exactly what is going on with each independent variable. The last table, collinearity diagnostics, is about, is there a multicollinearity between variables? Okay, so let's start from the top. So the values you will look for are the one that I put in the slides. So the SIG of the ANOVA table is less than 0.05, and is 0.001. So we can say that some independent variables that we chose are predicting the dependent variable, which is the willingness to buy 5-seat economy cars. Okay, so something is going on here. So we can say that we reject the null hypothesis because there is something, there is an effect, okay? Then we look at the adjusted R square, which is 0.175. So the way we interpret this part is that about 17% of the variability in the willingness to buy economy cars is basically explained by the independent variables in our model. This is the way you interpret the adjusted R squared as a percentage. So because it's 0.175, you use the 17%. If it was 0.25, you can say it's about 20%, okay? So the other value we are looking at is the standardized coefficients beta. So this one, which is different from this one. So we talked about this. This is considering the movement, the change of the standard deviation of the independent variable, which is causing a change in the standard deviation of the dependent variable. This is instead one unit change, every 1 unit change in the independent variable is causing a change in the dependent variable. So we're looking at this one because it is more easy to interpret, okay? So we say that for size of hometown or city, as independent variable and willingness to buy an economy car as dependent variable, we have a beta of minus 0.322. What does that mean? That means that this is suggesting that for every 1 standard deviation increase in hometown size, so this part, independent variable, we are expecting a decrease because there is a minus here, a decrease in about 0.32 standard deviations in the willingness to buy economy cars. Okay, this is the way you interpret this part. For the marital status, we can say that with an increase in standard deviation, there is an increase in standard deviation for the desirability to buy economy cars. So this is the way you interpret the minus and the plus sign, okay? So what does that mean? That means that there is an increase in size of town and is causing people to not be willing to buy economy cars because an increase is causing a decrease, okay? So an increase in the independent variable, which is the size of hometown, is causing a decrease in desirability to buy economy cars. Then we look at the multicollinearity. So the value that we need here is, so we have a lot of data here. We need the BIF. So even if you have a lot of data in the collinearity diagnostics, we are looking at this part. BIF. So we said that it should be less than 10 in order to not have the multiple linearity, which is a bad thing. So we have for size of home 1.0, for gender 1.05, marital status 1.1. So we're good to go. That means that those independent variables are measuring different things. Okay, so this is what you will need to do in the assignment, and these are the values that you have to look for. This is, of course, a simplified regression model, but for now, this is everything you need to know. Okay, thank you.